We continue with section 3C, dealing with uncertainty. And in this video, we'll cover problems 4 and 5. Problem 4 relates to absolute and relative errors, and problem 5 relates to precision and accuracy. Absolute and relative error. We've talked about errors. It is possible that a measurement has an error, either systematic or random. Either way, we want to know if this error is small enough that we can ignore it or large that we cannot ignore the error. So we need some sort of measurement of the magnitude of this error so we can make a decision about whether to ignore the error, go with it, or make sure that we fix it. So let's look at the first one, the absolute error. Describes how far away a measured value is from the true value. The minute we say how far, it clearly points towards difference, which is a minus sign. So we have absolute error is equal to measured value minus true value. It's the difference. The distance is, when we say how far, we're talking about how far either to the left or to the right of the true value is the measured value. So it's the measured value minus the true value. The relative error is comparing the size of the error to what is the true value of the measurement. So absolute error is the numerator, and we're comparing it to the true value, which is the denominator. So the ratio, the fraction, gives us the relative error. Relative error can also be expressed as a percent. So we go 100% times 100%. That gives us our answer as a percent rather than a decimal or a fraction. Now, remember, we've discussed this before. Multiplying a number by 100% is multiplying it with 100 over 100, which is really equal to 1. Problem 4 gives us two examples of how absolute error and relative error are measured. Let's look at the two problems. So we have part A, the label on a bag of dog food says 30 pounds, but the true weight is 29 pounds. So the measured weight or the claimed weight is 30 pounds, but the true weight is less by 1 pound, so it is 29 pounds. So using the formula for absolute error, which is the measured minus the true weight, is equal to 30 pounds minus 29 pounds, and that is equal to 1 pound. That is the absolute error. Now the second step is measuring the relative error, which is equal to, using the formula, measured value minus the true value over the true value, because relative error is a comparison of the absolute error to the true value of the measurement. So 30 minus 20 by the formula, which is equal to 1 pound, divided by the true weight, which is 29 pounds. The pounds and the pounds get canceled, and the relative error is 1 over 29. And sometimes it is hard to see what the relative error is, and seeing it as a percent makes sense. So 1 divided by 29 is equal to, let's write this down, 0.034. You can add another decimal place if you want to. Maybe I should round it to the fourth decimal place and make it a 5. So that is the relative error. And if you want to see it as a percent, all we have to do is multiply it with 100%. percent. The percent is our label. We multiply the number by 100, so you don't even need a calculator. You just shift the decimal point 2 places to the right. That amounts to multiplication by 100, 3.45%. So if we want to decide whether to ignore this error or to pay attention to it, this is the number that will help us make that decision, depending on our level of tolerance for errors. Now, the next problem, an order of fish and chips is supposed to cost $8.95, so $8.95. So let's take that as the true value. However, uh, the server accidentally keys in a price that is different from what is the true value. It's $9.95. So the absolute error is m minus t, the measured value minus the true value, which is equal to $1. That is the absolute error. That's one way of measuring error. Now, the next one is looking at it as a percent, and that is taking the relative error, comparing the absolute error to the true value. So that gives us 9.95 minus 8.95 divided by the true value, which is 8.95. That gives us 0.11. And if you want to see the relative error a little more clearly, it's easier to think in terms of a percent. It makes us look at things in a better way. So that would be shifting the decimal point 2 places to the right because we're multiplying it with 100. So I get 11, but of course I absolutely need to put that percent symbol there. If not, the meaning of the number changes completely. So that final answer is 11%. 11% error in a money transaction is quite a bit. So I don't think we can ignore this sort of error. One more example of calculation of absolute and relative error. The actual distance is 13.34 miles, but your measured distance is 13.0 miles. So we have 13.0 miles as m. The true value is 13.34. The absolute error is m minus t, which is 13 minus 13.4 miles, is a negative 0.34 miles. So errors can also be negative. Now we need to find the relative error. So we're comparing the absolute error to the true value. So we have the absolute error divided by the true value, which is negative 0.03. And if you want to see this as a percent, you go negative 0.03 times 100%, which is equal to negative, we shift the decimal point to the right by 2 places because we are multiplying by 100. So multiplying by 100 gives us negative 3, but of course, don't forget the percent symbol because multiplying by 100% is equal to 1, which means you're not changing the value 0.03. So your relative error is negative 3%. In problem 5, we discuss accuracy and precision. So let's look at problem 5. Let's move this up. Your true height is 62.50 inches. A tape measure that can be read to the nearest 1/8 inch gives your height as 62 3/8. There's an error there. Your true height is 62 3/8 inch. A new laser device at the doctor's office that gives readings to the nearest 0.05 inch gives your height as 62.50. So we have a true value and we have two measured values. So what is accuracy? Accuracy is how close the measured value is to the true value. That is the term that describes accuracy. How close is the measured value to the true value? So that is accuracy. Now, precision is related to the uh, amount of detail in the measurement, which means how precise is the measurement tells us what if I have a measurement that gives me details up to the second decimal place. That is its precision. If I have a measurement that gives measurements or values up to the third decimal place, that is its precision. Now, if we had to compare these two values, which one has more precision? This measurement has more precision because it goes up to the third decimal place. So we have two types of measurements. One is a tape measure, and the other is the laser device. Let's look at the relative errors of these two measurements, and whichever is the smaller would be closer to the actual or true value of the measurement, which is 62.50. So that's how we're going to compare the accuracy of these two measurements by comparing the relative errors. So the relative error for the tape measure, we use the formula, plug in the numbers. The true value is 62.50. That's the true height. And this is the measured height. So measured height minus the true height divided by the true height is negative 0.002. So we look at the doctor's office laser device and figure out the relative error, which is the absolute error over the true value, and it is equal to 0. So there is no doubt that the doctor's office measurement is more accurate than the one with the tape measure. This is to just bring to your attention that we want the relative error to be smaller, but really what we want it to be is closer to the true value. Even though negative 0.002 is less than 0, that doesn't make it more accurate. 0 is the value of the measurement that is closer to the true value. So this is an example of why we do not consider the negative sign when we compare uh, two relative errors when we're trying to figure out which of the two is more accurate. Now, how do we compare precision? Precision tells us about the decimal place to which the measurement is uh, accurate. So let's look at precision. So the tape measure measures to the nearest 1/8 of an inch. So we convert 1/8 to a decimal, so it's easy for comparison, to the measurement at the doctor's office, which is given to be 0.05 inches. 0.05, that is the precision to which the measurement at the doctor's office is clearly less than 0.125, which is the precision of the tape measure. So the doctor's office is definitely more precise than the tape measure. Here's another problem where we compare two different types of measurements and see which one is more accurate and which one is more precise than the other. So your actual weight or your true weight is 52.55 kilograms. A scale at the health clinic measures to the nearest half kilogram and it shows a weight of 53.5 kilograms. There's another measurement, which is a digital scale at the gym, and it shows to the nearest 0.01 kilograms, gives your weight at 51.48 kilograms. So let's see which one is more accurate than the other and which one is more precise than the other. So comparing accuracy would be possible only if we figured out what the relative errors in each case are. So the health clinic relative error is measured minus true over true. We take the true weight to be 52.55 and the measured weight to be 53.5. Doing the calculations, we get 0.0181, which is about 1.81%. The gym uses a digital scale, and the relative error is again the measured weight minus the true weight over the true weight, and it gives us a negative 2.036%. So we obviously ignore the signs of the relative errors, and clearly 0.0181 is less than 0.02036, which proves that the measurement in the health clinic is closer to the measurement in the gym. So therefore, the health clinic gives a more accurate weight. Now we compare precisions. The health clinic is true or precise to the nearest half kilogram, and the gym is precise to the nearest 0.01 kilograms. Now, the gym scale, which is precise to the nearest 0.01 kilograms, since 0.01, which is the precision of the gym scale, is less than zero point 0.5, which is the precision of the scale in the health clinic, the gym is more precise than the scale in the health clinic. So this is an example of where the gym has more precise measurement. However, the health clinic gives a more accurate measurement, which means accuracy would mean closer to the actual or true weight. So precision does not imply accuracy.